Okay, I'm gonna turn the page because we're going all the way to 32. There you go. Okay, so there's the answers to that. All right, so, okay. Now you also had homework in Go Formative. You had 63 through 72 yesterday. And I think that it's important that we talk about some of those. So let me go in to that. Your quizzes are open, by the way. Sorry. You can go in and look at your quizzes. Email me if there's any issues, or if there's something you need to discuss with me. But let me go to my Go Formative for the review for the final. So no one submitted, obviously. Okay, so yesterday we did 63 through 72. Finals review. Okay, what questions? Let's go to it. Let me just talk about each one. So we have a lot to do today. Okay, so on this one, you had to find the volume of the cylinder and find the volume of the cone. The radius was 4, okay? And you guys are able to see your answers as you go through them, right? So I think that that's helpful. The value of the variables. So opposite the 90 is 2x. So that means that opposite the 30y is 10 rad 3. So that's good. Then you find x by multiplying it by rad 3 again.
Miss Grant?
Yeah.
We can see our answers from the quiz, but we can't see our scores.
Okay, I can fix that in a bit. Right now I want to go through this, but I can work on that. Does anybody want me to do, what can I do? Well, if I stop sharing, I think this might work. Hold on a second. There we go. Okay. So in this case, you guys can see the board and me, right? Yes. In this one, this is a hard challenge problem, but the only value I have is opposite the 90 degrees, which means opposite the 30 degrees is, this is 2x. So this is half, you know what, the lights, sorry. 3.5 rad 6. So 3.5 rad 6 here is my opposite 30. And then, so I'm trying to find x, right? Then opposite 60 is my x rad 2. So this is x rad 2 is going to be 3.5 rad 6 times rad wait, no, sorry, x rad 3 is opposite. I'm getting confused with this 45, 45, 90. Okay, so 3.5 rad 18, work it out. You can break down 18. I'm going to do 3.5 times 3, because this is 9 times 2. 3.5 times 3, 7, 10.5. 10.5 rad 2. That is my opposite. My 60 degrees, which means it's also opposite the 45 degrees. Since this is an isosceles triangle, 45, 45, 90, this is also 10.5 rad 2. And this is x rad 2, which means 10.5 rad 2 times rad 2. 10.5 rad 4, or 10.5, simplify rad 4, times 2, 21. Okay.
Miss Grant, do we have to put the go formative answers into the notebook?
No, because I can just grade them myself. So that's how you do that problem. That one's the hardest for sure. Look at it, it's difficult. Okay, then here, this isn't difficult at all. Find the ratios of tan Y and tan Z. So I'm doing tangent Y opposite over adjacent. Well, I don't know what the angle measure is. So I'm going to do tan of Y equals 3 over X. I'm going to have to do, you know what I'll have to do first? Opposite over hypotenuse. 3 over rad 34. Even though it didn't ask me for sign, the only way that I'm going to be able to find an angle measure, I have to find an angle measure. The only way I'm going to be able to find an angle measure is if I use the information I'm given. I was given opposite. I was given hypotenuse. 3 divided by rad 34. Let's get them in decimal format, please. Opposite over hypotenuse. 3 divided by rad 34. Okay. 0.51. Nope, that can't be. Opposite over hypotenuse. Oh, it's in 3 rad 34. Ah, sheesh. Okay. Huh. You guys, they left. They left the angle measure in the answer key in radical form, which is fine. Okay. So that means that I then use this information to find tan, which would be, you know, I could say tangent Y equals opposite over adjacent. I just found angle Y. 3 rad 34 over 34. So what you're doing in this problem is you need to find the angle, and then once you find the angle measure, you do ratios like this. So this would be tan. Okay. I have a lot more to do this period, so I can't stay on. Is there any others from Go Formative that you have to see, that you really, really want to see? I could do one more before we go on to our today's 1 through 36 in the packet and 38 through 54 in Go Formative.
Could you do 72?
Yep. Okay. So here's 72. And on 72, I'm going to do, okay, X degrees. Well, here's what I know. Opposite over adjacent. Tangent of X equals 19 over 11. In your calculator, this is you doing second function because I don't know the angle measure. So it's going to be tan or second tan. So the buttons are second tangent, and then you do 19 divided by 11. I'll do it. 59.9 degrees, 60 degrees. Okay. Second function when you don't know the angle measure.
Thank you.
Yeah. Okay. So now we are back. And we are doing the, let me pull it up real quick. We're going, so we already did page 1 and page 2, all the way to 32 problems. Now I'm going to start on this page. It's page 5. Interior angles. Let's make the homework, because all these problems are very much like the same thing over and over again. So what I'm going to do is I'm going to give you for homework tonight, I'm going to alter it because I'm giving you Go Formative and paper. That's a lot. And of course you have to work hard when you're studying for the final, but for me to give you like 50 problems in one night, it's a bit crazy. So let's do 2 through 36 even in the packet. Okay. That'll make it a little bit not so insane, right? Here we go. Angles of polygons. We are in chapter 6, guys. This is chapter 6 of your textbook. Sum of the interior angles is 180 n minus 2. We practiced this last week, actually. You know, remember when I had to find the area of a hexagon, an area of a pentagon? I had to do in a pentagon, how many degrees total? And then I divided by 5 in a pentagon to get each angle. So the sum of the interior angles is this. The sum of the exterior angles is 360. Each angle is going to be the sum of the angles divided by the number of sides. Number of sides. And each exterior angle is going to be, because you know, all the exterior angles added together is 360. So I'm going to divide by however many sides there are. So I could say that's going to be the sides. But you know, sides. If it has 5 sides, then it has 5 angles. If it has 3 sides, it has 3 angles. So that's the same number. So now we're just going to do the evens. So I'll do some of the evens for you. And we're going to do this all the way until the bell rings. So I'm going to be able to get a lot done with you. And you'll have to do the Go Formative, a lot of the Go Formative on your own. So I'm going to scroll up. Let's see, I can do 360 exterior. 360 divided by n is each exterior, right? In case you want to see it as we go, 180 n minus 2 is the angles total. 180 n minus 2 divided by n is each interior angle. I really could go for like a truly brand new black marker right now. All right, here we go. 2, 4, 6. Let's do some of these. Here we, yeah, that looks good. The sum of the measures, so I know the sum of the measures. It's 12, or I'm sorry, 16, 20. How many sides does it have? Well, if it has 16, 20, ooh, look at that. Oh, beautiful. That's the sum of the measures. The sum of the measures is 180 and minus 2. So I know that the answer is 1,620. I set that equal to 180 and minus 2. To solve this, divide both sides by 180. Solving for n, right? 1620 divided by 180. 9. Okay. Add 2 to both sides. $11 sides. I think you can do number 4 on your own. 6. If an exterior angle of a regular polygon measures 15, that means that each exterior is 15. Look up here. Each exterior, I don't know how many sides though. So I'm going to do 360 divided by n equals 15. And then you solve for that. Okay, you all need a calculator, handy, ready to go. Okay, let's move on. Let me fill in this chart for you. Just so you're all clear on the properties and there's no confusion on quadrilaterals. Opposite sides are parallel. That has to be a parallelogram, a rectangle, a rhombus is like a kite, a diamond shape. Those opposite sides are parallel, and a square, all of them. Opposite sides are congruent. That's not all of them. That's going to be opposite sides are congruent. A rectangle, sorry, it doesn't say all 4 sides. Sorry. Opposite sides are congruent. Yeah, in a parallelogram, yep, all 4. Diagonals bisect each other. Pretty good. We're still doing all of them. Yep. Opposite angles are congruent. There's a lot of 90 degrees in the rectangle and square, and the rhombus, the opposite angles are congruent. So I can do that. All the way until consecutive angles, it's everything. All the way until, so the opposite angles are congruent on all of them, and the consecutive angles, the 2 angles, like the top 2, add up to 180, or the 2 side ones add up to 180. The diagonals are not congruent in a parallelogram, but they are congruent in a rectangle, and they're congruent in a square. Yep. Diagonals are perpendicular, just the rhombus and the square. Diagonals bisect opposite angles. That's going to be just in a rhombus and a square. And remember, guys, I'm recording this, so if you need to go back, you can. Let me make sure no one's in the waiting room because period 0. Sometimes people are a little sleepy, right? All right, I'm moving on. I've got to get all the way through 36. Some of them though, actually, oh good, I do need to cut some of these out. Isn't that great? So it's going to be 1 through 23, or 2 through 22, even, and then 29. So I actually just edited your homework. I'll fix that on Google Classroom too. All right, let's go on to the next page. We're going to talk about quadrilaterals. Let's see, 10 or 14, 12, 16, okay. Parallelogram, rectangle, rhombus, square. Parallelogram. If the measure of ACD is 7x minus 12, so the whole thing is 7x minus 12, that's the whole angle, and BDC, that's the bottom right angle. So I've got the bottom left angle is 7x minus 12. The bottom right angle is 10x plus 5. Well, what did we say about consecutive angles? Someone tell me on Zoom. Well, everyone's on Zoom. I'm alone in this room. What did we say about consecutive angles?
They're supplementary.
Supplementary means add up to 180. So I'm going to do the two angles, 7x, minus 12, plus 10x plus 5 equals 180. Awesome. Measure of angle PSQ is 6x minus 13, PSQ. That's just this one right here. 6x minus 13. And PQS, this one right here, x plus 5. Hey, heads up. This is a triangle right here. This is a 90-degree angle. That means that 90 plus this make 180. Three angles in a triangle. 6x minus 13 plus 90 plus x plus 5. Or I could also say, since I know that this is 90, these two also make 90, right? The other two angles in a right triangle make 90. 6x minus 13, 6x minus 13 plus x plus 5 equal 90. So there's that one. I hope you guys are with me because I'm doing lots of good stuff. And you'll solve for number 12. Just solve for x on number 12. Let me jump to 16 just because I don't have time to do every single. Okay. 16. I guess I don't need that anymore. If WYX, that's this angle, is 13x minus 7. Well, guys, it's a square. What do I know about this angle that I just drew right here? It's a square.
45 degrees.
Thank you. 13x minus 7 equals 45 degrees. Solve it. Trapezoids and isosceles trapezoids. Trapezoids have only one set of parallel lines. The parallel sides are called the bases. Let's label it A, B, C, D. Here's my parallel, right? Parallel sides are the bases. That's AB and DC. The non-parallel sides are called the legs. That'd be AD and BC. Okay. An isosceles trapezoid means that these two sides are the same, the two legs. So they're still gonna have parallel here. The legs are congruent. The diagonals are congruent. Let me draw them. Diagonals. The base angles, boom, boom. If it's an isosceles trapezoid, the legs are congruent and the base angles are congruent. The opposite angles are diagonal, like D and B, A and C, supplementary. So B and D, angle B plus angle D make 180. Angle A plus angle C make 180. Okay. Let's go on to the next. All right, trapezoids. So the only even number in the trapezoid section is 18. So can you guys look at 18? The mid segment of a trapezoid, we draw one. The mid segment is my middle line. Its length, the blue, is equal to the average of, so here's base 1, here's base 2, here's my mid segment. My mid segment is half of base 1 and base 2. That would be like, for number 19, we would practice that one. Maybe I'll do number 19 for you. So I'll do 18, I'll do 19. Which I really need to do this then. Okay. FCD is 8x minus 1. 8x minus 1. EDC is 3x plus 39. It's an isosceles trapezoid, which means that my legs are congruent. Sorry. If my legs are congruent, my base angles are congruent. So I can say that 8x minus 1 equals 3x plus 39. Sorry, wow. I just blow my nose, huh? So I would set those equal and solve for x. $19. Oh, and please notice that it doesn't say solve, it doesn't say find x. It says find DEF. So plug x into, okay. Once I find out what the 3x plus 39 is, I should actually just do this one. It's hard. 5x equals 40, x equals 8. Yeah. Okay. 3 times 8 plus 39. I don't know. 24 plus 39 should be something 3. 63. So angle CDE equals 63 degrees. That means that now this is 63 degrees. What did we say about these angles? And if you look at it and you think about what we learned first semester, if they're parallel lines, these two are same side interior. That means that something plus 63 makes 180. 180 minus 63 equals DEF. It's 117. Okay. $19, I said I do. Does anybody have any questions? No one's really talking except for me. Do you have any questions? The mid segment, 3x minus 21 is equal to the bases cut in half. So I add the bases together. And then I could just divide by 2 or multiply by 1/2. Remember, they mean the same thing. So that one's actually something fine that you can do without my help. I think that if you're stuck, the easiest thing to do would be to multiply by 2 on both sides first. Because then 6x minus 42 equals x plus 38. And you can go from there. Did I do that right? Yeah, I did. Yeah. Okay. Distance formula for number 20. Let's do it. Now, this section that I'm about to start is actually a little bit of chapter 9. And we need to talk about perpendicular lines and parallel lines. So here we go. This topic, it says topic 3, but that's chapter 9 in our book. We only did one lesson of chapter 9. We did 9.1. 9.1. And we talked about the distance formula. We talked about parallel lines, perpendicular lines. So parallel lines have the same slope. That's from algebra 1. Perpendicular lines have opposite reciprocal slopes. Okay. So here we go. Q is located at -6, -1. So if I were to draw a coordinate plane, and S is located at 1, -5. Find RT. Well, remember on a rectangle, the diagonals are equal. Which means that the distance from here to here is equal to RT. So QS is congruent to RT. What do I do to find the distance of QS? How long? What would I do? Anybody? The distance from Q to S. I'm giving ordered pairs. Hello. No one? Are you still there?
Distance formula?
Distance formula. Let me write it down for you. The square root of x1 minus x2 squared plus y1 minus y2 squared. If you switch it and do x2 minus x1, you just subtract the x's and square it. Subtract the y's and square it. So here we go. Square root of -6 minus 1 squared plus -1 minus -1 minus -5 squared. Careful. -7 squared plus 4 squared. So the distance is going to be the square root of 49 plus 16, the square root of 65. Well, 65 is nothing special. So if I wanted it in decimal form, (8.0). It's like 8.06. It's, you know. RT is 8.06. All right. On 22, Z is located at -7.3. And X is located at -2.8. Find the slope of WY. Z, X, and WY have perpendicular slopes. Which means you find the slope of ZX and then step 2, the perpendicular slope is WY. So it's basically like y minus y, 8 minus 3 over -2 minus -7. Oh, 5 over 5. So my perpendicular of 1, because 5 over 5 is 1. ZX, the slope is 1. Perpendicular slope, just -1, opposite reciprocal. That was easy. I'm doing a lot of these for you. That's good, because you still have the go formative, and we all know that the go formative questions are harder. Okay. So then, we only have a couple minutes left. Then, the only thing that you have to worry about is number 29. And you don't even have to go to 36. We're done. 29 is your last one. So I edited your homework, remember? 2 through 22 even. On paper, comma 29. And look, I'm gonna do 29 right now. All right, scale factor means that I'm going to increase a shape. I'm going to double it or triple it. I could even cut it in half, cut it into a thirds. So right now, on this one, on 29, I need to dilate this using a scale factor of 1/3. So you need to multiply each ordered pair or divide by 3. You cut into thirds. By 1/3 or divide by 3. A is -15, -3. Well, if I need to dilate this by a scale factor of 1/3, K means the scale factor, then I'm just gonna do, what's -15 divided by 3? -5. What's -3 divided by 3? -1. So you go through each ordered pair, and the new shape is going to be like over here. This would be my new A. So you can tell that if you drew it, you don't have to draw it. If you drew it, it would also be a much smaller shape, shrunken down, closer to the origin. So on Go Formative, you're doing 38 through 54. It's about these topics. Okay? And we're going to go through that in class tomorrow, which will be here in person, right? So let me stop the recording. Today was a lot. You guys, that's what finals is. Like, this is not just like, oh, so quick. Let me stop the recording.